はい、皆さん、こんにちは。自然エネルギー財団研究員の岡田紗代と申します。今日は、
Good afternoon, everyone. This is Sawa Okada from Renewable Energy Institute. And we have this webinar series, preparing for the mandatory implementation of building LCA in Japan in FY 2028. I would like to share the screen. First of all, this webinar has a simultaneous interpretation service, and please click interpretation button on the screen and select the language you wish to listen. So preparing for the mandatory implementation of building LCA in Japan in FY 2028, how the system would change the practice, the experience of France. So what is a building LCA? I would like to provide you with a brief explanation. Building LCA includes a supply chain. So it's a calculation of a CO2 emission that includes the entire supply chain, from material manufacturing to the logistics. And that is a whole life carbon surrounded by a green dashed line, and then operational carbon. So the carbon operational carbon is subtracted, and that is embodied carbon. So the whole life carbon and embodied carbon are the terms you will hear during the seminar today. In Japan, in 2028, the buildings exceeding 5,000 square meters will be obliged to notify, and explanation system for all buildings will also be introduced. This is a roadmap issued by MLIT of Japan. The first step is LCCO2, embodied carbon and whole life carbon, the evaluation. It will be mandatory for the building exceeding 5,000 square meters. And in 2030, or within 3 years from the start of the implementation, the expansion of the scope is envisioned. And the upper limit will be strengthened, or the more stricter upper line control will be implemented toward 2030. And the situation of EU and other major countries, depending on the country, take for example Sweden, 2028, and the Netherlands. Even before that, the draft proposal for evaluation method has been drafted. So the situation is different country by country, but 3 years or 4 years from the implementation, usually the upper limit control becomes stricter. And today we will hear the situation of the France RA 2020. And draft was prepared in 2018, and in 2022, the upper limit value was introduced. In other words, LCA notification was implemented in 2022. And last year, 2025, the upper limit became stricter. And in 2028, upper limit is likely to be even stricter. So the operators and building material manufacturers and other players, how they are responding to this movement will be explained today. And today's speaker is Ms. Lailia Volo, the head of Lab 4, who's based in Paris and Tokyo. And advisory services to real estate investors, developers, and design teams on environmental strategies, innovation, and long-term value creation. Ms. Lilia,
Hi,
welcome to this webinar.
thank you very much, Sayu, for the kind introduction, and thank you for the Renewable Energy Institute for inviting me to participate in this webinar. Um, and thank you everyone for joining. I will now share my screen. So as Sayo introduced today, I would mostly speak about the ARI 2020 regulation, which is the main LCA framework in France. And I will first talk more about how the regulation work, and then show you through two different projects how that has influenced the way designer and investor look at projects. So for a little bit of context, France had a number of regulation since 2010 with the first environmental forum. And since 2010, there's been a number of different law, and especially in France in 2015, we had the first national carbon strategy, which is a strategy that established a roadmap to carbon neutrality for every single industry, so including the construction industry. So this first strategy in 2015 proposed targets for scope 1, 2, and 3 of the construction industry. And this progressively resulted in the ARI 20 regulation. In between the implementation of the ARI 2020, there was experimental program called E plus C minus, who started in 2017. E plus C minus stands for energy positive and low carbon. And this voluntary certification had 4 level of energy and 2 level of carbons, and the idea was to test the threshold that the ARI 2020 was going to impose later on. And in the ARI 2020 was actually came into application in 2022 with 2 major measure, which is that now there's a mandatory carbon threshold for all energy use, and we'll go more in detail about this later. And there's also another threshold about the whole life carbon, which this one is also limited by typology, and as Sayo explained, is gradually tightening. There are, of course, other regulation in France that regulate energy for the building industry, but I will not go too much more into detail on this today. So in France, the construction industry weighs heavily because it represents a quarter of national emissions. The numbers showed on this page are for the year 2022, but the order of magnitude is still the same. So it's the second highest emitting sector in France after transportation. This is why there's a lot of political attention on this sector. And the roadmap for 2030 is to reduce the emission by 40% compared to when the first national strategy was emitted in 2015, with slightly different objective when it comes to energy impact, carbon impact, and materials carbon impacts. So the 4 main guidelines for the building sector is first to have an evolution of the energy mix, which is to have more buildings that works on electricity rather than natural gas and other fossil fuels, to make a big effort in renovating the existing building stock so that buildings are more energy efficient and thermally efficient, to also focus on the way we conceive new buildings so they're themselves more performant, and also the actual equipment that is installed in the building to promote both sobriety in uses, which means not over equipping the buildings, and that the equipment that is installed is very efficient. So that from 2015 to 2030, the energy carbon weight will decrease by 45%. The material decrease to 30%. And another particularity of France is that it's also encouraging carbon storage, notably through a methodology called dynamic LCA that we'll explain a little bit more in detail later on. So to understand well, of course, the ERI 2020 didn't come out of nowhere. For the longest time, France had thermal regulation that were applying to energy through the different RT. So these were regulation that only apply to energy consumption. And then, as I said, in 2017, we had a voluntary certification that first introduced carbon threshold, and then in 2022, the ERI 20 that both apply to energy consumption and CO2 levels. As of now, the ERI 2020 only concerns new build. It's mandatory for new build, but it doesn't apply yet to renovation. So for now, for renovation, it's only energy level threshold that are regulated. But people can also do voluntary labels, such as the BBCA renovation label, that will talk about likely on the example we'll go through, because the methodology is very similar to the ERI 2020. So the particularity of the ERI 2020, as I said, is that it's the world's first environmental regulation in the building sector, meaning that it actually have 3 objectives instead of just one objective, which most regulation have and usually focus on energy. The ERI 2020 focus on energy, carbon, and comfort, which is quite particular. So of course, in terms of energy, the idea is to prioritize energy sobriety, so encourage people to use less energy, and also energy decarbonization, so that the energy that is actually used comes from less carbonated power sources. The one on carbon is mostly about the carbon impact of building construction, as we will see. And the comfort one, it's maybe a bit specific to France, that it's heating up extremely rapidly. France is one of the countries in the world that will see the effect of climate change the fastest. And so the indicators on the comfort level ought to ensure summer comfort during period of extreme heat. So the ERI 2020 understands that different building typology would not have the same consumption level, the same layout, and the same materials. So it has different thresholds for each building category. And in 2022, it started to be applied to housing, offices, and schools. And then last year, since the beginning of this year, it extended to new building typology with adapted threshold that match kind of the construction techniques that are typical of this kind of buildings. So in practice, the ERI 2020 for a design team will change the process at 2 stages. The first stage would be during the building permit stage, so in the design phase, where the design team will have to provide an attestation of compliance with energy and environmental requirements. That means that during the design stage, a full energy study will have to be transmitted, and a design stage LCA. So this LCA will have to show that it respects the carbon threshold of the ERI 2020, though it's understood that the building might change a little bit throughout the change of the stages after that. If for some reason the design team fails to meet the threshold, then the building permit will be refused, and they will have to redesign the projects until the threshold can be made. So that's why the ERI 20 have a strong impact on the construction sector, because it doesn't impose financial punition, But if design failed to meet the RE20 threshold, the project can be delayed by several months, which is very costly from anyone. And if for some reason the building fails to meet the threshold from the architectural point of view, if we can show that there was negligence on the design side, is professionally may be engaged. The definitive compliance attestation for the RE20 is delivered after the building completion. So once the building is delivered, an updated energy study that match exactly what was built need to be computed, and as-built LCA, which take in account what actually happened during construction, needs to be furnished, and there's also airtightness tests that need to be provided. Again, if for some reason the building is not conforming, this will have like more severe consequences with insurance involvement, and the architect's liability could be engaged on this stage. So most of the time, um, that's why for the first stage, most people prefer to have a margin to be below most threshold by at least 5%, so that if the building is modified, it would still manage to be compliant at delivery. So the RE 2020 is based on indicators that each have a specified units. There's 6 main indicators that are regulated by thresholds. The first category of indicator is, of course, carbon, which with 2 indicators that are capped. The first one is the carbon impact of construction. So that is the carbon impact of all the components that go in the building and the site work. And this first indicator is calculated through full cycle assessment, so full life cycle assessment. In France, and as in most countries, the LCA is based on a 50-year reference study period. To do the LCA, you have to use the national French database that contain all EPDs of different manufacturers. This database is called INIAS, and it's in open access. I will explain a little bit more in detail what it looks like later on. And the LCA needs to be computed through an approved LCA softwares. So the software might be provided by a private company, but they will have to be approved by a government body to make the LCA for the RE20. The second carbon indicator is the energy impact. So it's expressed in a kilogram of CO2 per square meter per year. So it's a little bit different from the construction impact, which is over 50 years, as I said. And this is the impact of all the primary energy consumed in the building. So that includes all the different kind of use, such as heating, cooling, hot water, lighting. So in terms of energy, there's actually 2 indicators for energy consumption. The first one is the total primary energy consumption, and the second one is the non-renewable primary energy consumption. So it's this one is really encouraging to search for renewable energy vectors within the building. So some buildings would have their own on-site renewable production, or will connect themselves to a provider that can, let's say, increase the part of the building energy that is coming from renewable. The 2 last indicators are, let's say, relatively innovative, because the third one concerning the energy is the BBO, which is the bioclimatic needs of the building, which means what the building needs in terms of heating, cooling, and lighting before any equipment is installed. So it's the intrinsic building performance coming from the architecture alone, which means the massing and the inertia of material and the air tightness. So this indicator is really encouraging design team to think in more bioclimatic needs, and not to do a building and just shove a lot of equipment in it later on to manage the temperature. So this has also influenced the way people design quite a bit. And then the last one, the one that is about summer comfort, is expressed in degrees hour of discomfort. So it's the level of thermal discomfort that occupants can perceive during the warm season. So to calculate this one, a simulation of indoor temperature using ARRI 2020 climate file will see what temperature are reached inside the building, and they will be compared every hour to a temperature that is considered comfortable. And if they're above that threshold, they will accumulate to calculate overall how many hours per year the building is not comfortable. So as our focus today is LCA, I will now mostly talk about the two first indicator, and maybe even just the first indicator about the carbon impact of construction. So all these different impacts show how you can break down the carbon impact of the global project. So the global project is going to be the carbon impact of the building and the carbon impact of the plot it's on. And then the carbon impact of the building itself is going to be the carbon impact of construction, so meaning equipment and materials, plus the carbon emission linked to the actual construction time. And added to this, the impact of the energy used in the building over 50 years and of the water use over the 50 years. So we have all these indicators, but the ARRI 2020 asks us put a cap only on the two top ones in blue. And that's why we will be looking at these two more in details. So what is interesting to understand in France and globally is that every country will have a different relative weight of embodied carbon versus operational carbon. In France, because we have nuclear energy, the intensity of carbon of a kilowatt is quite low. So compared to Europe or even the UK, it's about like 10 times lower. So in general, even over 50 years, it's always going to be the embodied carbon, meaning the carbon related to material and equipment, that's going to weigh the most. With this statistics being usually around 80% for embodied carbon and 20% for operational carbon over 50 years. So these are numbers taken from the ARRI 2020 caps for the 2025 for an office building. So now I would go more in detail about the impact of construction. How do we actually calculate it? And so it's again broken down in construction lots that actually correspond to the way we conceive the building. So there's three main categories. The main one, and the one that will have the most impact, is what we call structural work, with elements like the structure, the foundation, the facade, and the roof. Then the second category would be for architectural that are linked to finishing, so partition and floor, wall, and finishes. And the third party would be for more like equipment, so HVAC, plumbing, etc. So because historically there was less environmental data about equipment, the categories that are in gray are not calculated in a detailed way yet. They usually work with a lump sum values, so the estimate is a little bit less precise than for other category. But in the future, they should also be subjective to detail calculation. And I will explain a little bit later how the detail calculation is carried away. But when you're in the design stage, the lots you will focus on in priority would be the one in red, because they're the one who have the heavier impact. And so that's where you can make the biggest difference on the overall impact of the project. And so as Sayo briefly explained, to be compliant to the ARRI 2020, you have to show that the impact of construction is below a certain threshold. And this threshold is decreasing every 3 years. And the idea is to let the industry time to adapt and become better at building low carbon So both designer and manufacturer can improve the way they conceive and the way they produce. And also, it's differentiated per building type because typically offices usually have layouts and equipment that requires more carbon, so they have a higher threshold than, let's say, housing. And so what it means is that now in this period, so anyone that has applied for a building permit after January 2026 had to comply with the 2028. And after December 2028, we'll have to comply to this threshold until this one, which is the final threshold after 2031. So now we'll go a little bit more into how the dynamic LCA works. So France uses LCA with a similar methodology than the rest of the world, but we will see that end-of-life emissions are accounted for slightly differently. So as Sayo explained, life cycle analysis represents the products in building life over a certain period, which is 50 years in that case. And it's divided in three main model and a sort of bonus model, which is module D. The first module A is for everything that happens before the building is delivered. So A1 to A3, it's really how the materials are produced from raw material extraction to the emission links to the transformation into product. Then A4 and A5 are for transporting the materials from the manufacturing site to the construction site. And A5 is the emission that are linked to when the building is implemented. Then a B phase is when the building is in operation and accounts for emissions that are linked to maintenance, repair, and such like this. And the C stage is when the building is demolished and how are the materials disposed of. So the emission to transport them to a waste processing facility and to dispose of them. And module D is for certain material where the manufacturer has kind of think about how they could be reused or recovered. So this is actually emission that can be avoided if the material is recycled or reused, and they always corresponds to negative emissions. So in a traditional static LCA, the emission at each phase A, B, C are just simply added without any difference depending on when the tons of CO2 is emitted, whether it's emitted day one or 40 years later, 1 ton of CO2 is the same. The dynamic LCA is different for emission that happen after the end of life. They are discounted by a factor. So the emission for during delivery and operation are the same, but at the end of life, there's a discount. And it's so the emission is multiplied by a weighting coefficient that is inferior to 1. And as we say, that is decreasing over time. So the reason for the dynamic LCA or from a political point of view come for, let's say, three main reasons is that like people that did the RE 2020 wants that there's a sense of urgency in solving climate change. So the idea is to avoid maximum of emission now. They also consider that what happens at the end of a building, the end of life scenario, are relatively uncertain, so it's hard to weigh the emissions then. And also part of it is also that there's a kinetic degradation of greenhouse in the atmosphere. But this methodology is relatively controversial because the coefficient used, as you say, is just linear, so it's relatively arbitrary, it's not very science-based. And an emission that will happen in 50 years will still have a strong impact for future generations. So for some people, it's slightly discounting the future to use this methodology. But the main effect of the dynamic LCA is that it really encourages materials that can have carbon storage. And as I said before, it's part of France policy to strongly encourage carbon storage. So how does it work exactly? If we take a bio-based material like wood, when the wood grows through photosynthesis, it would store some CO2 and release oxygen in the atmosphere. And the storage capacity varied from wood type, but it's about 1.5 kilogram of CO2 per kilogram of wood. So it's a pretty important storage. And of course, once the wood is harvested, the CO2 stayed captured in the wood. And while the wood is used in the building, the carbon is stored in the building. Though at the end, when the building is demolished and the wood is disposed of, either burnt or it starts decomposing, then the CO2 will be released again in the atmosphere. So now if we look at a wood product using different methodology, if you look at the production phase, the emissions are negative because that's when the wood is growing and capturing CO2 through photosynthesis. Then when it's implemented in construction site with the transportation and maybe the cutting, etc., there's a little bit of emission. During the use of the building, there's no really change because the wood is stable and there's no exchange. And then at the end of life, when the wood is decomposing or burnt, then it would release the CO2 it had initially captured. So with static LCA, then the wood still have, you know, the carbon weight. But if we take the dynamic LCA, the three first phases are accounted for the same. But then at the end of life, we discount the emission using the coefficient. And then we result in the wood having negative emission. So that's why the ERI 2020 methodology is strongly encouraging bio-based material because you can have negative emission in your LCA. But as I said, I mean, that's why the wood utilization has progressed a lot in France. But of course, some people think this method is a little bit controversial. So in general, where do we find environmental data to do the LCA? So as I said before, French has this national database, which is called INES. It's open access, so you can have a look if you want to see what it looks like. And on this, we have French EPDs, which we call FDES, but their structure is exactly like other country EPDs. And when you enter the national database, materials are organized by category. So there's facades, roofing, isolation, etc. And then the different manufacturer can have their products here. And so this database have been in place for more than 10 years, but it's being enriched more year after year as more manufacturers start to produce their own EPD. But to kind of manage the lack of data at the beginning when there was very little manufacturers that had put the data on the base, the French ministry had issued what we call DED, which is default environmental data. So for example, if you want to use a product and the manufacturer doesn't have an EPD, you will have to use the default environmental data for that type of product. But because these are not very precise because we don't know exactly the condition in which the material is produced, they're usually heavily weighted by a factor, so as to overestimate a little bit the carbon impact. So usually it's a bit penalizing for a project to use default environmental data. And then we have manufactured issued EPDs. The one for equipment such as HVAC are called PEP, and the one for materials called FDES, but exactly the same principle. And they can be either individual, so a manufacturer will issue its own data sheet, or if it's several smaller manufacturer for who is hard to support the cost of an EPD on their own, they can do a group EPD as long as their product have very similar properties. So for example, if it's a local wood producer and there's 5 wood producer in the same area with the same methodology, they might issue a collective EPD for the wood product. And then, yeah, the EPD has to be, of course, third-party checked before it's uploaded to the national database. So in the actual EPD, there's the information you'll find is which standards are used, which unit is used, and then how long the project lifespan is, so how many the time it needs to be. And then the result of the life cycle analysis for that product are presented like that with the modules vertically, And then here, the actual CO2 impact. So this is a weak product again, so we can see that the growing phase is negative again because that's when the wood captured the CO2. And then, so once you have the carbon impact all um, for all for all of your equipment. So as I said, for each EPD, it will tell you the carbon intensity per unit. So for example, if this is a plant and the unit is a linear meter, you will see how many linear meter you have of this plant. And then if, for example, it indicates that the uh, lifespan is 25 years, you'll know that you have to replace it twice. So that's how you do your calculation to know over 50 years what is the carbon weight of these plants. And then you add that for every single material. And then one thing that's interesting to note is that, of course, from one
Lelia.
material, from one
Hello,
manufacturer to
Lelia.
the other, there can be a lot of variability in the actual carbon intensity of a product. Especially we can see here for concrete, then you have now extremely low carbon concrete that can compete with timber, but it also can go very high if there's like no effort from the manufacturer side to reduce carbon. And
Lelia.
equally for wood, depending of where it comes from, transportation can still have a big impact. So even if you use wood, sometimes you can end up having quite a high impact if the wood comes from quite far away. So now I would speak a little bit about how this is actually used in projects. So this is a first visual to understand a little bit how LCA are usually visually transmitted to designer and clients. So it's just, I talked a little bit before about the 13 architecture lots. And so we usually visualize the weight of each lot and how it results. So for this particular example on the left, we can see that the facade has quite a big impact, and also HVAC equipment. They're probably the two things that would be a priority to work on. And then usually we put the threshold limits, and it's good at design stage, as I say, to be at least 5% below the limits, because during construction, the project will likely evolve, and to make sure that this is respected over time. So in terms of methodology, I would say the ideal thing is to try looking at the LCA as early as possible. So during design competition, we all know that time is tight, but if possible, it's preferable to do a first simplified calculation just to check that the overall structural and facade principle and materials that the team is intended to use could respect the boundaries for carbon impact. And then as soon as concept designs start, I usually recommend to do an LCA at least on the three main architecture lot, which is the foundation and structure, the facade, and external lot, because for some project, this would be the external work will be extremely low, but if you in an urban setting with a metro line or things like that below, this can actually weigh extremely heavily. So these are the, let's say, three things that are gonna determine if a project can make it or not. And then after you start the first preliminary design phase, usually the idea is to do one first full LCA and see how the project is doing against the threshold it's aiming at. And then after that, just do LCA on small iteration. So for example, on variance on the facade or on variance of the structure until you manage to lower the impact. And then, of course, at the end of the detailed design, a final full LCA is needed again because it's the one that will be reported to client and to the authorities if needed. So to speak a little bit about different roles in the project, I mean, the architects of the world has to coordinate the various stakeholder, and they will be mostly responsible for bioclimatic design. So as I said before, in the RE 2020, there's also two indicators that regard summer comfort. And the bioclimatic design is going to influence a lot what the structure materials are. And as I said, the facade usually have a heavy weight, so that's why it's a big factor in the project carbon impact. And also things like material choice and soil protection solutions. The rental engineer is probably the main protagonist because he's the one who will do the LCA calculation at different stage, and he kind of needs to have a good understanding of order of magnitude. He's probably going to be also part of the proposal to improve the project impact, and he will also have to produce thermal simulation and daylight analysis. And depending on the result, the facade again or the structure might be modified if you need to increase thermal inertia or reduce glazing. And this change will, of course, impact the LCA calculation. So these three types of computation kind of need to be done regularly. The mechanical engineer is mostly involved in the definition of the systems and the equipment. And as we saw on the previous slide, the HVAC can have a very important weight on the project. So talking with a mechanical engineer to be sure that it doesn't over-design equipment is important. And then, of course, the facade engineer is both going to devise like which kind of materials are used in the facade and its need in terms of soil protection. And I will see in the next example that sometimes soil protection can weigh extremely heavily on projects. So that's also why having a good facade concept is kind of critical. And finally, the structural engineer, because I think the use of structure is probably one of the main determinants of whether it's going to be easy or not to reach a carbon impact, because that's when you usually have the most material. And so all these technical consultants are in constant discussion with the cost consultant, because actually they usually describe the specificities of the systems they recommend, and then the cost consultant will be the one who actually estimates the quantity of the materials needed, and you will transmit back this quantity to the environmental engineer in order to run the LCA. So a typical project will look like that. As I say, in competition stage, it's great if you can do a simple FI LCA. Then in the concept design, LCA on just the main workloads, structure, facade, and external work. And then when primarily design starts, doing a first complete LCA, and then smaller LCA just on the variants that are proposed by the design team. And at the end of developed design, a final LCA that would be the kind of the one that's transmitted before the as-built LCA that happens after the building is completed. So of course, the earlier you try to reduce carbon in the project, the easiest it is. So this is kind of the order of magnitude by which you can hope to reduce carbon at different stage. And of course, when you approach kind of construction execution, when structural and facade decisions have been made, it's extremely hard to significantly vary carbon. So this is a little example of what kind of simplified LCA you can do at concept design stage. So as I said, the ARI 2020 threshold and most certification threshold is over the total material equipment. So in order to have an idea if your structure and facades are in the right order of magnitude, usually what we try to do is have a database of several projects that comply with the overall carbon impact we want to reach. And we look at typically how much carbon they spent on structure and facade to see how we compare. So we can see that in this project, at first, we were a little bit above, about 15% above what a typical project would achieve. So then we started to work on variants to get below these numbers. So, and I think it's important to get the facade and structure in order before you start working on other stuff, because of course this is going to determine a lot of other things in the project. So when you enter preliminary design, sorry, we did the first, for this project, for example, we did first full LCA, and we could see we were a little bit above. And so then you kind of see on the right, we've broken that by big category. and you can see that the facade is waiting for 26% of the impact. So that's the first thing we started to work on. So here we can see just the carbon impact of the facade elements. And so this particular project was a courthouse that the objective was for it to be very bioclimatic, so that the office part will not actually use any air conditioning. And so there was a little bit of tension between wanting a very glazed facade, but wanted to have very good solar protection. So the initial design have a lot of aluminum sunshade on all facades, and that resulted in that being way too intense in terms of carbon. So we had to redesign this part with using more spaced aluminum sunshade, so we could reduce the overall numbers. And also on some facade, we decided that they were actually already naturally shaded and they didn't need the same concentration. So we had, let's say, a more refined design where all facades were not treated the same. And so usually to help with decisions, we try to make a little summary of the different variants and how they impact carbon. So here are all the recommendations from the environmental engineer to reduce the carbon of the structure, the interior, and the facade. So for the structure, generally, if you use concrete, one easiest move is to switch the type of concrete you use. So in this case, we use more low carbon concrete type, which sometimes have longer setting time, so you can delay a little bit construction or like lengthen a little bit the construction period, but it's very efficient to reduce carbon. And then these two are also using different steel, so lower carbon steel than what was initially produced. So of course they have usually a slight financial cost because low carbon structural products tends to be more expensive. In terms of interior finishes, a very popular strategy right now in France is having instead of using new carpet, having carpet that come from reuse manufacturer. And now quite a few manufacturers have positioned themselves in offering these services. So they collect used carpet and they kind of restore them, so they look like new, but of course they have a much lower carbon impact. The only limitation is sometimes they have limited quantities. So depending on the size of the project, you may not able to have exactly the same carpet every floor. But for a smaller project, it's definitely a good solution. And as I said, for the facade, so on some facade, we decided not to put some aluminum shading. And then also there was some wood used in the facade, and we specified that the wood had to come from France, so there's less transportation and it will also result in lower carbon. So that's on the left, it's like the LCA before these variants are implemented, and we can see we were above the threshold. And on the right, it's after that. So you can see that the facade is still, predominant, but overall we managed to reduce a little bit the thing to be on the threshold with not a very comfortable margin, just 2% below. And then that will be my last example for the day before we talk about Q&A. So this is actually a renovation project. So the ARI 2020 does not apply, but the building was aiming to get a certification, which is called BBCA, and that use also carbon threshold that works exactly the same as the ARI 2020. So I think it's an interesting example to look at. So the particularity of this building, it's a heritage building. It's from the early 1800s, and 3 out of 4 facades are listed. So it means you cannot modify them aesthetically. And the thing was that we wanted to improve drastically the energy performance of the building, but because the facade were listed, it was not possible to add insulation to the outside. And then it was neither possible to add insulation to the inside because from an investor point of view, we're going to lose too many square meters. So he was not going to be able to rent enough square meter to make the finance work for that building. So the only solution was to improve the windows performance by a lot. And so the building had double glazing, and the window frame had been replaced less than 10 years ago. So we didn't really want to have to throw away all the window frames. So we developed a methodology where we reused most window frames and then retain in place another part. And the thing was that we needed to have a glazing that had the performance of triple glazing, but the existing window frame were too narrow to allow for the thickness of triple glazing. So the solution we ended up using was to use a double glaze with a vacuum cavity. So standard double glazing is composed of two glass pan, as you know, and then the inner layer has a type of gas, which usually is argon. Um, and in the vacuum glazing, there's no more gas, so there's no more convection in the central cavity. So the thermal conductivity is much lower. And it's just a space ceramic beads that prevent the two layer of glass to collapse. And as you can see, the overall thickness is lower than the normal double glazing and much lower than the triple glazing. So that was the first aspect of the solution. And the second part is that from this manufacturer, we also ask that the glass is made of low carbon glass. And so this manufacturer had developed this low carbon glass process where you can see on the left how glass is usually produced and the different things they implemented to reduce glass carbon content. So first of all, in the composition, 50% of the content is from recycled glass. And then the sand used is sourced locally, and they also use low carbon soda ash. Then in the manufacturing process, they use different type of furnaces, which are more high efficiency. And they also use electro boosting, which is just using renewable electricity instead of fossil fuel. They also have on-site renewable generation, energy generation, and they purchase renewable energy. And overall, in the production chain, they optimize different phases so that the energy use at each phase is more efficient. And lastly, they also work on transport, where they transport the materials through waterways and gas-powered road transport instead of regular diesel road transport. So this is just the final stage to compare the, let's say, 4 glazing solutions that are in use or in France. There's nearly no more single glazing. So this solution is just, as we see here, the thermal transmission is way too high, so that would not be able. That was kind of the solution that was existing. So we can see the performance still is still better, but not that optimal. And then that's the solution that was put in place with the vacuum double glazing with low carbon glass, and it both minimize the thermal transmittance even compared to triple glazing, and also has the lowest embodied carbon. So that's why this solution was implemented. And on top of that, it was compatible with reusing the existing window frame. We also help improve the carbon impact. And yeah, that's it for my presentation. Thanks a lot for your attention, and I'm happy to continue through a Q&A if you have any questions.
はい、ライリアさん、ありがとうございます。
Thank you very much.
次のセッションなんですけども、私が
Turning to the next session, I would like to share the screen.
質疑応答で、
So this
Q&A
is the
セッションで
question and answer session.
質問を用意させていただきま
I
した。
have prepared several questions,
時間も少し限
but
られております
time is
が、
running and
一
quite
つ目の
limited.
ご
But
質問なんで
nonetheless,
すけ
if
れ
I
ど
may
も、
ask the first question, for
RE2020 によって設計
how has
何が
RE2020 most
変わった
significantly
のかというご質問
changed
をし
the
たいと思い
design
ます。
process,
いかがでしょうか。
particularly in relation to buildings LCA? Please.
Yeah, thank you for your question. So I think the main thing that has changed is probably the type of systems that are used. I mean, French traditionally has a lot of concrete building, and there's a lot of concrete manufacture, but in 5 years now, most new construction is actually made of timber, so have a wood structure. So there's been a big change in let's say what is considered a common system to be used. And also, I think that yeah, designers have become more involved in choosing the material and developing kind of thinking of new solution. I think some architects also take a stand to start building in stone again because it's got good thermal inertia, and French actually has that as a natural resources. So it kind of have made some materials re-emerged and some become less prominent. And also, I would say the discussion with clients now, carbon is an indicator that is always compared to financial cost, whereas before I felt financial cost was always predominant. Now it has more similar weighting in decisions.
なるほど。ありがとうございます。コストとカーボンが同じような指標で、比べられるようになって。
Thank you very much. Cost and carbon can now be compared using the same type of metrics. That is a major progress. Moving on to the next question. So, what were the main challenges when the RE 2020 was first introduced? The embodied carbon thresholds were relatively achievable, but they provided the industry with a clear direction and were designed to become more stringent over time. So the practitioners, I would assume that the practitioners took this more seriously. And every 3 years, the threshold becomes more stringent. So what were the changes that you observed in the behaviors of the designers or the structures?
Yeah, so I think the progressive threshold, in my opinion, were relatively good methodology. I would say when ERI 2020 first came in place in 2022, a lot of people kind of lack knowledge and preparation. I think it took a few people by surprise, and some projects didn't manage to get a building permit and were put on a hold. And I think that's when people started educating themselves, and then of course they started to be also like this more webinars and things. So I think first, yeah, the whole design team with consultant and architect have to change the methodology in terms of how regularly they have exchange. And then, of course, the second big part is on the manufacturer side. And also that's been driving by the demands from designer. So I think some type of manufacturer had anticipated more because they had naturally lower carbon products. So everyone that worked in the wood industry or the bio-based material, I think were more aware because it was more profitable for them. And I feel maybe the carbon industry took a little bit more years to adapt, especially maybe bigger producer. But France is a country where there's a lot of research on material, and so especially for concrete, there's a lot of new process of how to reduce the more carbonated element in concrete has developed. So I think it's the fact that the EPDs are public. It makes for relatively good transparency of information, and it kind of helps manufacturers to challenge each other and reach like lower carbon product.
ありがとうございます。やっぱり上限値
Thank
が
you
設
very
定され
much.
た。
And with the thresholds being given, so the materials manufacturers are competing with each other, and carbon in terms of the unit seems to be reduced, and new industries seems to be appearing, and how you calculate the methodologies has also changed, it seems. Thank you. Thank you for the answer. Next, this is a salient characteristic of France, the dynamic LCA. If I may ask a question on dynamic LCA, amongst the EU countries and globally, France is quite unique, if I may say so. For dynamic LCA, you are looking into the future, not static, but you have opted for dynamic LCA. And how do the practitioners in France perceive dynamic LCA? I would like to hear your view, your take.
So yeah, I think dynamic LCA, maybe from a designer point of view, is not so challenged because they're not really the one making the calculation. They see, let's say, the result. And I think overall in France, the architectural profession has kind of enjoyed starting to design in wood. So I think wood is a material that has some property that suits quite a few architects. I mean, it's of course less common than in Japan, where wood is, let's say, historically predominant. So I think for designer, they they embraced it quite quickly. I would say more it's more the concrete industry that regularly question that, and also more from a mathematical and scientific point of view. So I think if you see the publication of research lab on the methodology, it's more the weighting of the coefficient that is not really linked to any physical, uh, you know, uh, measure. So I think, yeah, different fields. So I feel scientific it's more for the mathematical aspect of it. Designer, I think they actually like that they can use more varied materials than concrete. So I think it's been well perceived, and it's more manufacturers that are not working with bio-based material that feel there's a slight unfair competition. I think what one thing to notice is, as I presented earlier, this whole regulations come from French national strategy, and this is a strategy that have a roadmap for every industry. And the other industry that is involved is obviously the wood industry. And France actually historically have a very large forest, but it's not exploited very efficiently, and we don't have the means to transform the wood locally. So France exports a lot of, let's say, raw wood, and then re-imports it when it's transformed in construction products. So I think the strategy was to, put a measure in the construction industry that would also encourage the wood industry. So in that regard, I think maybe the government needs to invest more money in the wood industry so they can match the demand, because right now what's happening is that then more wood is imported from abroad because we don't manage internally to satisfy our own demand.
まだありがとうございます。ダイナミック LCA で、非常に産業自体が建築の、
Excuse me. So dynamic LCA
というところも非常に大きな変化が生まれている。
has had an impact on selection of materials. In Japan, forestry industry uses lots of timbers, and therefore I think there's a lot that we can learn from French experience.
の質問に、
Let us move on to the next question.
次はですね、発注者の方、LCA をどの程度理解し、設計判断に、発注者の方が、関与しているっていうのでしょうか。
So I think in terms of client, it's extremely variable. The level of knowledge. I think, I mean, a little bit like in Japan, different owners and different investor will have different thesis about where the market is going. I think one of my former clients, for example, is AXA, the insurance group, and because the future of the insurance business is extremely linked to climate change, I think when they also invest in real estate, they're very sensitive to this question. And I would say internally, they have equipped themselves with teams that have their own modelings and their own reference. So, for example, there'll be a client where it's relatively easy to discuss carbon reduction measure. I would say other clients, cost is still the prevalent metrics for them, and sometimes it's a little bit harder for them to understand the arbitrage. But I think what has worked the best for me is doing, the little table that I showed earlier, showing the different variants and how each variant, in terms of changing a little bit the structure, a little bit the facade, and showing what the carbon reduction for each variant is, it's very useful. And usually in that table, we also put a column where we put the price change. So whether this is gonna, increase or reduce the cost of the project. I think that has helped facilitate the discourse with clients. Yeah.
今のお話で、
So,
少し出ましたけれども、
it was mentioned just now, the relationship between cost and LCA. For example, if you would like to reduce the embodied carbon, would it become more costly? Or by changing the industry, the framework, perhaps it may not have that much of an impact on cost. If you could give us your view on this.
Mm. So I think overall, unfortunately, is usually a little bit more expensive to do low carbon projects because like it's more specific produce and the amount that is produced right now is sometimes more limited and or the technology is still relatively new. I would say it depends a lot on other constraints because, for example, a low carbon isolation system that develops in France is through using hay. So hay is a byproduct of agriculture that actually is considered a waste by farmers. And so now in some part of France, for residential area, they use large blocks of hay for isolation. And so if you're in a not very dense area where you can afford to have a few square meter, that's actually a very good low cost solution. But if you apply the same solution in the city where the rent is so high per square meter, that's too many square meters to use. So for isolation, I feel because a lot of people are developing bio-based isolation made of hemp, of hay, etc. They can be a good low cost thing, but they're usually much wider. So it depends how much space would cost. And also you have, let's say, sometimes kind of trends impact. So, for example, the RE20 came in place relatively close to the Olympics in Paris. And so Paris had to construct a whole Olympic village, and every single building in the Olympic village was wood structure. So there was a huge demand for wood structure at the same time, and the price became extremely high compared to what the teams had anticipated. And most of the wood had to come actually from Canada. So sometimes you also have kind of pressure that are momentarily that would increase cost. But yeah, there's a few things like, for example, reuse carpet is actually pretty cost efficient because the like renovating the carpet is not a very complicated process. So I think a lot of flooring solution actually sometimes it can be cheaper, but I will say for structural and facade, it's usually more expensive.
ありがとうございます。ちょっと時間を延長させていただきます。
Thank you very much. And so this one is the last question. I think we went over the allocated time. Thank you very much, Ms. Lilia. Next, I would like to share the screen. So questionnaire survey. There's a QR code. You can read a QR code with your smartphone, but we will send the QR code with the materials, and by July the 14th, please fill out the questionnaire. So the next webinar will be on July the 31st from 16 o'clock to 17 o'clock. We will have an expert from UK to talk about their experience. Moving on to the next page. So the Institute's event on July the 17th, there will be JCI seminar. So how Europe will realize competitiveness, energy security, and decarbonization. On July the 23rd, there will be a hybrid event, RE Users Summit 2026. So if your time allows, please do participate. So we had the pleasure of welcoming Ms. Lailia to learn about French experience of LCA. Thank you so much.
Thank you so much.
This concludes today's event. Thank you very much for your attendance.